As education facilities break up for summer, it's time for the educators to recuperate and replan for the new academic year. I'm your host, Paul Hames from industrial software company PTC. In this podcast, we share the moments where digital transforms physical and meet the brilliant minds behind some of the most innovative products around the world, each powered by PTC technology. The opportunity to learn and grow through education is an incredible part of your life, and perhaps one that lasts a lifetime with constant knowledge building and the want to learn. Now, here at PTC, we realize how important the education journey is and that today's students will be the engineers of tomorrow. It's important to us and to future employees that they're equipped with the knowledge of first-class technology during their education. Technology that will enable them to hit the ground running once they start their careers. So with me today on this education special episode is someone who knows all too well the value of education, Jordan Cox. Now, Jordan spent the last 30 years working in industry alongside teaching in academia. He also heads up PTC's education segment. Jordan, I recently read that the US alone could be facing a shortfall of more than 6 million engineers. And if you couple that with companies wanting to reshore their manufacturing, it looks like we aren't churning out enough student engineers. So firstly, why do you think that is? And how does technology play a hand in enticing more students to take up engineering?
Well, thanks, Paul. Both of those questions are excellent questions. And let me start out with the first one of why do I think that we aren't churning out enough engineers? First of all, it's not just an issue with the US, it's really worldwide. We just don't have enough engineers. And a lot of it, I think, has to do with kind of two issues. The first issue is that most students don't even know what engineers are or what they do until they enter university. And it's too late then because they haven't really been prepared in the math and sciences. And so they end up not being successful. So the first aspect of solving that problem is starting to introduce engineering and the understanding of what engineers do earlier in the educational learning path. The second aspect of it is that I don't think students are introduced to the technologies of engineering and really understand how to use those and how they're used in industry to really better, human life on the planet.
Yeah, I think those are great points, Jordan. I certainly see that we as a company, we do all we can to provide those educational establishments with access to our technologies, and they in turn embed some of that into the curricula. But I think it's challenging on both sides, challenging for us to keep track of what the university needs, but also for those education establishments to keep track of how quickly our industry evolves. If you think about just the digital transformation use cases that we talk about today, tough for the universities to keep up to date with all of that.
Yeah, Paul, I think you bring up two really important issues. First of all, it's important for us to provide the latest technologies to universities so that students who are actually studying engineering and technology have those tools and those technologies. So they're prepared once they graduate to move into the workforce. That's a very important component of PTC's education program. But a second aspect of it is to actually move earlier in their education program into the first grades up through high school and introduce those technologies to them. Now, there are two problems with that. One is most of those schools don't have the technology infrastructure, meaning, people who are trained or necessarily the hardware to run that technology. And the second issue, and I think this is the biggest issue, is that most of the educators are not really trained or have experience in the STEM topics. Oftentimes, what I see is a school will decide to offer a STEM program, and rather than hiring a person who has the background to be a STEM educator, they pick one of their existing educators and say, now you're the STEM leader. And that educator, we get requests all the time from educators saying, gosh, do you have anything to kind of help me get up to speed with these technologies? So I think that's a real issue. And maybe it's an issue where we need to look at trying to prepare them, these educators, when they're studying education at the university level, to start getting familiar with some of the STEM technologies.
And I think I particularly want to pick up on, I think, the first point you made about understanding what actually the role of an engineer is, the broad range of engineering roles that exist in industry today. But I think there's also that issue around role models, people in the public eye that are seen to be doing great things because it has an impact on the environment that we live in. So, for example, I think Johnny Ive, who was the head of industrial design at Apple for many, many years, his impact on all of our lives has been huge. And he's known to many of us that are in the industry, but is he a household name? I'm not quite sure. And I think we need people like him to be put up as the role models, and as somebody aspirational that will inspire that younger generation of engineers or industrial designers, whatever it may be. People need to see more of those individuals and their contribution to our lives.
Yeah, I totally agree, Paul. Another aspect of this is the fact that when you work with young children, one of the things that you discover is there is a burning desire in them to help. They want to help. They want to contribute. And so STEM programs that really focus on either solving problems in the local community or solving worldwide problems is really important. It's what gets these students excited because they want to contribute. And I think that's a key element to really getting students excited.
So let's meet somebody who is living proof of what can happen when you inspire young people with careers in engineering and technology. High school graduate Steve Sandhoop, based just outside Dusseldorf in Germany, has developed a surgical robot that can perform knee surgery on its own. An amazing achievement that's simulating the world's first surgery in a classroom.
My project was to build and construct from the scratch an own robotic arm, which should simulate a surgical operation at the knee. I've constructed the robotic arm completely by myself. I've had reference from a real robotic arm, which is used at surgical operations. And I've also 3D printed and modeled an anatomically correct leg on which the surgery is then simulated at. So the robotic arm is completely in white to further emphasize its use in surgical operations. It consists of two axes which are forward oriented, that they look like a crane in front of him. And then there's a big base, which is like a big plane, which is used to rotate him in horizontal directions. At the end of the robotic arm, there's a drill, which is in the size between a needle and a scalpel and not as large as a normally sized drill. So in order to start the robotic arm, you have to plug in your USB cable to the laptop and put the power supply connected to the power outlet, and then have to start the software. So the main difference between my robotic arm and this one we can find in hospitals, mine one is functioning completely automatic, that you can control it through the software at the laptop. And in difference to the hospitals, they are still using assistive robotic arms which are assisting the surgeon. For my project, I've worked with a hospital which is in Kleve in a German town, and they gave me financial support and also a surgeon of the hospital. We've chatted together. I have sent him images of what my knee replica looked like. He then responded and gave me advices how I could make it more anatomically correct. Our school has made great effort into enabling our students to have further insight into STEM subjects, and my teacher, Herr Lachmann, which is responsible for our IT infrastructure, has made the effort that we have built a Fab Lab, which stands for Fabricating Lab. Labs with laser cutters, 3D printers, and all sorts of machines. I was lucky to be at that school, to have access to all these kinds of machines. Not only being supported through the knowledge of how to use them, but also financially even. I feel really proud of my project because at the start, it's quite a journey, I think, throughout the project, that I started with the little prototypes that I couldn't believe that I ended up with such a complicated and big robot arm at the end then. The project has definitely made me more curious about all the kinds of subjects I had to delve in this project, that from physics to anatomy to mechanics. I think I've learned really much. Also, resilience, I think, is a big part of it, that you're also going through the project, that you never give up.
Steve Sandhoop there. And what a brilliant case for showing how important it is for students to have access to leading technology during their education. Now, Jordan, how is PTC supporting academia in that way?
So, Paul, PTC aims to enable the workforce of the future by providing resources and support for students, educators, and academic institutions interested in learning and teaching PTC's technology and software solutions as part of their STEM programs. The types of offerings have evolved over the 23 years since PTC first launched its initiative by creating the PTC Education Program. And offerings now include free and discounted software, original curriculum materials, online courses, certification, and engagement programs, just to name a few.
That's fantastic. And again, we as a company continue to do all we can to make sure that our technology is fully available to supporting these types of projects for the future. Thanks to Jordan and to Stephen for telling us his story and talking us through his project. Please rate, review, and subscribe to our bi-weekly Third Angle episodes wherever you listen to your podcasts, and follow PTC on LinkedIn and Twitter for future episodes. This is an 1860 production for PTC. Executive producer is Jackie Cook, sound design and editing by Ollie Guillou, additional recording by Clarissa Maycock, and music by Rowan Bishop.